Today we're going to talk about how bones will develop, starting from a mass of either undifferentiated connective tissue or cartilage. And then we're going to talk about growth plates, aka epiphyseal plates. So to start off, our first type of bone growth is called intramembranous bone growth. And this is the type of process that occurs in your flat bones, okay? So the flat bones of your skull are ones that will grow using this process. So we're gonna start off with a mass of undifferentiated connective tissues that is just located near blood vessels. So there are blood vessels that are nearby and flowing through it. And the cells are actually going to differentiate into osteoblasts. So these are the immature bone cells that are going to actively produce bone tissue. And that's exactly what happens next. So the next step is that spongy bone is formed. So you remember that that is the type of bone tissue that has the little plates called trabeculae. So this is the type of bone that is formed first, as you can see over here. The next step is that the periosteum, so this is the dense, irregular connective tissue, it is going to form from the outside. So this is the covering for the bone. So we start with the cells building the bone tissue from the inside, specifically spongy bone. And then periosteum forms on the outside to help to cover the bone. And then in between these two, so remember that the spongy bone is around the center in the middle of the bone, and then the periosteum is on the outside. The next thing that forms is compact bone, again from these osteoblasts forming the bone tissue. But now we have compact bone that is formed in between the periosteum and the spongy bone. And that is our intramembranous bone. And if you were to cut or saw a flat skull bone and look like at that cross section, you would see that it is not a solid bone. You would actually have these little gaps that make the center of that bone look spongy. Okay, and that's because of the spongy. That is because of the spongy bone. So next we have endochondral bone growth. And this is a little bit more complicated, but not too much more complicated. So an endochondral bone is going to be representing most of the bones in the skeleton, okay? And the only reason why they're called intramembranous or endochondral bones is just because of the process in which the bones form. So we're gonna start off with a mass of hyaline cartilage. That's all it is. And then these cells that we have here in the hyaline cartilage are going to get bigger, and then they're going to die, and then eventually they are going to start breaking down. So that's exactly what is happening here. Next, the periosteum is going to form around our structure, just like how the periosteum formed in the intramembranous bone growth. The big difference here is that the periosteum is forming before any bone tissue is deposited on the inside here. Then blood vessels and undifferentiated connective tissue cells are going to enter. And just like last time, the undifferentiated connective tissue cells are going to differentiate into osteoblasts. Then spongy bone is formed, and then compact bone is formed. So this process in many ways is similar to the intramembranous bone growth. Some of the main differences are that the hyaline cartilage is our starting point here, and then the periosteum forms before any sort of bone tissue is deposited. And then once the periosteum forms and the connective tissue cells enter and become osteoblasts, then this cartilage, the dead cartilage is going to start breaking down so that these osteoblasts can then replace it with the spongy and the compact bone. So this is a nice big, little process chart that we have here that can show us exactly what's happening. So we have our massive cartilage. The cartilage cells are enlarging and dying, and then the periosteum forms on the outside. Then the blood vessels and the undifferentiated connective tissue cells enter and begin to replace the cartilage here with bone tissue. So there are cells that are going to help to break down the cartilage, and then the osteoblasts will help to build the bone tissue. And then notice that the center here is being broken down to form the medullary cavity where the bone marrow is going to be. Then over here, we have our ossification centers, and these are just the regions where the bone tissue is forming. So in the secondary ossification center, we have the spongy bone forming in the epiphyses. And then here, we're gonna have the primary ossification center within the diaphysis here, where compact bone is replacing the cartilage that is forming at the epiphyseal plate. So the reason why these bones are lengthening, well, this bone is lengthening, as you can see, going from here to here to here to here, is that this cartilage continues to grow. Okay, so the cells are reproducing, the cartilage, the cells are then, they are getting bigger, and then they are being broken down and replaced by bone. But the fact that the cells are continuing to reproduce and grow bigger, that is helping to lengthen the bone, so that then the bone cells can replace the cartilage with the bone tissue. And that's exactly what's happening at the epiphyseal plate. So the two primary ossification centers and secondary ossification centers just have to do with where it is. So the primary is within the diaphysis, where the cartilage is being replaced by the bone tissue with compact bone tissue here within the diaphysis. And then the secondary ossification center is where the spongy bone is just forming, and it's doing it in all directions within the epiphysis. So these plates right here, okay, these are the epiphyseal plates. You can see here that this bone is fully grown, so the epiphyseal plate is no longer active like it is here. But the epiphyseal plate is where the cartilage remains as the bone tissue is replacing it here, but the cartilage is going to continue to reproduce and grow and get replaced by bone tissue as it thickens. So that being said, the last thing that we're going to review is epiphyseal plates. So we're going to take a look at what exactly an epiphyseal plate is made out of. And I tried to keep it pretty simple, but essentially there are 4 layers within an epiphyseal plate. So this is just the band of cartilage located between the diaphysis and the epiphysis, as you can see here and here. And we have 4 layers. So we're going to look at the first 2 here. So going from where the epiphysis is here down towards the diaphysis, this is the first layer right here, where basically this tissue is just helping to anchor the cartilage to the epiphysis up there. The second layer, this is where all the action is happening. So these cells are reproducing, undergoing mitosis, and producing the cartilage matrix. And by producing more cells and producing the cartilage matrix, that's helping to thicken our plate here. And what that is also doing is that is pushing down the older cells down here into our 3rd layer. So the 3rd layer, these are the older cells. You can see that they are getting bigger. They're definitely a lot bigger than the cells that we have up here. They're getting pushed down by the 2nd layer, and that is thickening the epiphyseal plate. And that will help to lengthen the entire bone as this epiphyseal plate and then the other one on the other side of the bone continues to thicken. So then as we move down here, the osteoblasts are starting to secrete calcium salts down here and surround these cells with those calcium salts, and that is going to cause the cells to die. And that's what happens in the 4th layer. So we have dead cartilage cells here and calcified matrix, which is all well and good, but we want to have living bone matrix here. So eventually cells known as osteoclasts are going to come in. they're going to break down the calcified matrix, and then that will allow for the osteoblasts, which are our builders, to come in and deposit the bone tissue. Okay, so essentially what's happening at the epiphyseal plates is the cartilage is helping to grow, for the bone to grow, and then eventually it's being replaced by bone tissue. So it's kind of like providing a form or providing the structure here for the bone to then come in and replace. Right, so keep in mind that the epiphyseal plate is growing down in this direction. So all of the new cartilage that is being formed is being pushed down this way. And then the osteoclasts are going to break it down and replace it with bone tissue. And that is just going to happen over and over and over again as somebody is growing in each of that person's bones. And it will continue until the end of puberty, really, when somebody is at the end of their teens or even into their 20s. The very last thing that I have here for you are just a little bit, it is a little bit of information about osteoclasts. So these are really large cells, and they are what are known as multinucleated, meaning that it has more than one nucleus. So these cells are responsible for breaking down the calcified matrix. So that's what we have here. So they're going to produce chemicals that will help to break down the calcium phosphate and the collagen that you have within the bone tissue. So at the edge of the epiphyseal plate, that's where this is happening. So it's breaking down the cartilage, but osteoclasts are not just responsible for breaking down the cartilage with the calcified bone matrix. These will actually do this anytime they're called upon on normal bone tissue as well. Okay, so the action of the osteoclasts help to provide the place for osteoblasts to then come in to deposit their bone tissue. So the osteoclasts are responsible for getting rid of the cartilage, which did its job by helping to thicken the plate, but then eventually it's going to need to be replaced by living bone tissue. So the one thing that I think about when I see osteoclasts are these, which are Metroids, which is a very old video game, but they do have some newer games too. If any of you have ever played Metroid Prime or anything like that on like the Nintendo Wii or even GameCube. So it's just a fun thing. I think that the osteoclasts look a lot like Metroid. So if you remember that, that might end up being a bonus question at some point. So there you go. Metroid. And with that, we are at the end of this video. So make sure that you have your notes for each of these slides and upload them into Google Classroom.